vectors are represented in both magnitude and direction. Two vectors are represented in both magnitude and direction. See here, I am taking two vectors. One it is A vector, one more it is B vector. Two vectors having magnitude and direction. Two vectors having magnitude and direction. These two are two sides of the triangle. These two represent side by the two sides of the triangle. The resultant of these two vector, is the closing side of the triangle and represented in both magnitude and direction. So this is the resultant vector EC. About this is the triangle. Once again I am telling, two vectors represented in both magnitude and direction by the sides of the two sides of the triangle. Then their resultant is represented in both magnitude and direction by the closing side of the triangle. We can call it as a triangle law. We can call this one it is a triangle law. Now see here, A vector, B vector, these two are in order. We can call these two are in order. In order means what we can call means the tail of the second vector is the tail of this. This is, I told you already, this is a head of the vector and this is tail of the vector. The tail of the B vector is followed by the head of the first vector, head of the first A vector. This is nothing but a in order. And reverse order means the reverse order is nothing but a both are it is opposite direction. If the two heads are in opposite direction, that is in the reverse order. Okay. Now A vector, B vector in order and this C vector it is in the reverse order. The C vector it is in the reverse order. See here, just I am writing, if the C vector it is like this, the closing side of the triangle it is along this direction means all vectors are followed by the first another vector. At that moment you can write this is A vector plus B vector plus C vector is equal to 0 if this is the C vector. Now if this vector if you draw this diagram is like this, if you draw the diagram is like this, at that moment the closing side of the triangle it is, if you taken like this in a reverse order, the closing side of the triangle if you taken as a reverse order, A vector, B vector and this is C vector means you can write like this, A vector plus B vector, it is in reverse direction. So this is minus C. We have to write it is minus C bar, that is equal to 0. So A vector plus B vector is equal to C vector. A plus B is equal to C vector. Now this C is equal to, you can write C is equal to A vector plus B vector. C is equal to A vector plus B vector. This is the triangle. Once again I am defining the definition. Two vectors are represented in both magnitude and direction by the two sides of the triangle, then their resultant represented in magnitude and direction by the closing side of the triangle but in reverse order, that is called a triangle. The triangular formula it is A bar plus B bar is equal to C bar. And if you take it is polygon law, if you take the polygon law, it is also same. Polygon law is nothing but here, how many vectors we use it is 3 vectors. We are using it is the 2 vectors. Now, if number of vectors are represented by the both magnitude and direction by the sides of the polygon, See here, if number of vectors like this, number of vectors are represented, if the number of vectors are represented in both magnitude and direction, this is E vector if you taken, isn't it? By the sides of the polygon. See here, A vector is one side of the polygon, B vector is one more side of the polygon. So all vectors are by the sides of the polygon, and then their resultant. This resultant it is closing side represented by the magnitude and direction. This resultant is represented in both magnitude and direction but in reverse direction. So this is nothing but a F if you taken. At that moment F bar is equal to A vector plus B vector plus C vector plus D vector plus E vector. That is nothing but a polygon. Just I am giving the definition once again. Number of vectors represented in both magnitude and direction by the sides of the polygon taken in order, then their resultant represented both magnitude and direction but in opposite direction or in reverse direction, that we can call it is the polygon law. And next I will give the definition of the Lamis theorem. We can go for the Lamis theorem. In this one, Lamis theorem, what it is they given it is, if three coplanar forces acting at a point, three coplanar forces like this here, this is F1 vector, it is F2 vector and it is F3 vector. Three coplanar vectors are acting at a one point. This keeps it in equilibrium. If the particle it is in the equilibrium due to the F1, F2, F3, isn't it? That is directly proportional to sine of angle between them. Means now F1 is quite opposite to, it is nothing but there is an angle between the F2 and F3, it is alpha. F2 and F3 is alpha, and F2 quite opposite, we are writing it is angle, it is beta, because F3, it angle between the F1 and F3 is the beta, and angle between the F1 and F2 is the gamma. Angle between F1 and F2 is the gamma. We are writing this formula is F1 divided by sine of angle, it is alpha, sine of angle alpha, that is equal to F2 divided by sine of angle beta, that is equal to F3 is divided by sine of angle gamma. See here, F1 divided by sine alpha, when you are writing it is nothing but a F1 quite opposite angle. F1 force, we are writing F1 divided by sine angle is nothing but a F1 opposite angle. F2 divided by sine beta, when you are writing, where is F2? This is F2. So F2 quite opposite angle is the beta. So F2 sine beta is equal to, then F3 quite opposite angle, it is the gamma. So you can write it is F3 divided by sine of angle of gamma, isn't it? This is, we can call it is the Lamis theorem. This is about the Lamis theorem. Parallelogram law. What is parallelogram law means? Statement I am giving it is, two vectors are represented both magnitude and direction. Two vectors, P vector, Q vectors, isn't it? Two vectors represented both magnitude and direction by the adjacent side of the parallelogram, and then their resultant represented both magnitude and direction by the diagonal of the parallelogram, that we can call it is the parallelogram law statement. Once again we are defining the parallelogram law statement. See here, two vectors are represented in both magnitude and direction by the adjacent side of the parallelogram, and then their resultant represent, so R is the resultant represented in both magnitude and direction by the diagonal of the parallelogram, that we can call it is the parallelogram statement. Now I am writing it is P vector, Q vector, these two are the adjacent side of the parallelogram, and R is the resultant vector. Just I am extending this one here, one more, and isn't it? And this is one more vector here. If I extended, just I extended this vector like this, and I draw the one perpendicular line. Just I draw the perpendicular line and give the names. When I given the P vector, this is P vector and this is Q vector. So this is opposite also P vector, this is also Q vector. Angle between these two vectors is theta. Angle between these two vectors P and Q is the theta, and angle between the resultant and P vector is alpha. Angle between resultant and P vector is alpha. Now this angle is theta, means this angle also theta here, because this is P vector and this is Q vector, isn't it? Now we can write here OA is nothing but a P, and this is B, C and D we are giving. OA is equal to CD, that is equal to P vector. OA is equal to CD, that is equal to P vector, and OC is equal to OC is equal to AD. OC is equal to AD, that is Q vector, is it? And resultant is nothing but a OD. Resultant is the OD is equal to R. Resultant is the OD is equal to R. Now I am taking one right angle triangle DOB. One right angle triangle I am taking here. See here, this is angle 90 degrees. Now from this one, OD whole square is equal to, because it is the hypotenuse. Square of the hypotenuse is equal to square of the opposite side, BD whole square, plus square of the adjacent side. Here adjacent side is nothing but a OB whole square, that equal to OB whole square. OD square is equal to BD. It is the BD we don't know, it is unknown only. We are writing BD whole square is equal to OB. OB I am writing as a OA plus AB. OB I am writing as a OA plus AB. OA plus AB whole square. Now OD square is equal to BD square plus, it is A plus B whole square formula if you apply. What is A plus B whole square? A square plus B square. A square plus B square plus 2AB. 2AB. So here this is A, B, this is B, and A, 2AB we are writing. Now in this one, OD, what is OD here? R. OD is equal to R I am writing. R square is equal to, what is BD? BD is equal to unknown. We don't know that BD value. This is BD value, we don't know. So BD whole square plus OA. What is OA? OA is equal to P vector. OA is equal to P vector plus AB. What is AB here? This is the AB, but this one also unknown. We don't know that one. AB square also unknown plus 2 OA is equal to P AB. Now we have to calculate what is the BD value and AB value. From how we can write means from this triangle. This is the one right angle triangle again. DBA. It is one right angle triangle. From this one, this is the hypotenuse. Okay. Now cos theta is equal to adjacent side divided by hypotenuse. This is AB is the adjacent side. AB divided by, what is hypotenuse? Q. AD is nothing but a Q. Q is the hypotenuse. I am writing AB is equal to Q cos theta. AB is equal to Q cos theta. Next one, sin theta is equal to opposite side by hypotenuse. BD is the opposite and Q is the hypotenuse. This is the Q, this is the hypotenuse. So BD divided by Q. From this one, BD is equal to, we can write Q sin theta. Now it is equation 1, it is equation 2 and it is equation 3. Substitute equation 2, equation 3 in equation 1. Substitute equation 2, equation 3 in equation 1. At that moment, R square is equal to, what is the BD value here? BD is nothing but a 3, equation 3. That you can write as a Q square sin square theta, because whole square is there, plus P square plus AB. What is AB equation 2? That is Q square cos square theta plus 2P. AB is nothing but a, what is AB here again? Q cos theta. AB is equal to Q cos theta. Just I substitute equation 2, equation 3 in equation 1, isn't it? Now in this one, Q square sin theta, Q square cos square theta is there. What you can take common in this one? Q square if you take common, first I am writing P square I am writing. Q square in this one I taken the common. Here sin square theta is remaining. In this one cos square theta is remaining. Sin square theta plus cos square theta plus 2PQ cos theta. Now sin square theta plus cos square theta is equal to 1. We can write R square is equal to P square plus Q square plus 2PQ cos theta. Now the resultant R is equal to, resultant vector R is equal to under root of P square plus Q square plus 2PQ cos theta. 2PQ cos theta. It is the resultant. What is the direction of the resultant? Direction means this is, it gives the alpha gives the direction of the resultant vector. Here alpha gives the resultant of the direction. So tan alpha is equal to tan alpha is equal to, if you take the one more triangle again here, this is again one right angle triangle, opposite side by adjacent side, opposite side by adjacent side. This is triangle I am taking, OBD, one right angle triangle, OBD, opposite side divided by adjacent side. What is opposite side? BD, and adjacent side is OB. OB, how you can write? OB is nothing but you can write OA plus AB. OB you can write as a OA plus AB. OA plus AB I am writing. What is BD value here? BD is equal to, already we calculated, BD is equal to Q sin theta. I am writing in this one. Tan alpha is equal to Q sin theta divided by, what is OA? Here OA is equal to P vector. OA is equal to P vector. So OA is nothing but a P plus AB. AB is equal to, we calculated Q cos theta, that is equation 2. So Q cos theta. Now alpha is equal to, you can write tan alpha inverse, tan inverse of, tan I am taking that side, so tan inverse into Q sin theta whole divided by P plus Q cos theta, P plus Q cos theta. Alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. So this is the resultant of the parallelogram, and it is the direction of the resultant. Once again, just I am giving the definition and everything I am concluding. Now what is the definition means? Two vectors represented in both magnitude and direction by the adjacent side of the parallelogram law, then their resultant represented in both magnitude and direction by the diagonal of the parallelogram law, so that we are calling it is the parallelogram law statement, isn't it? From this one, just we are taking it is OBD, one right angle triangle, OBD. Just for your understanding, I am writing here the triangle, it is OBD and middle point is A. OBD, one triangle. From this Pythagoras theorem I have written the equation, isn't it? It is A plus B whole square formula applied here. Equation 1. In this one, BD and AB we calculated by using of this triangle. What about that is ABD? This is Q vector, isn't it? This is the theta. From this triangle cos theta sin theta I calculated both values. If you substitute in this one, we got it is R is equal to under root of P square plus Q square plus 2PQ cos theta, and resultant direction of the resultant alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. Next, further, if you taken, if two vectors are parallel, means how it is? If you coming to the diagram, see here, two vectors appears to be like this. Here. This hand is nothing but a one vector. The two vectors are like this. Angle between them is the theta. Angle between two vectors is theta. Now what I am saying, these two vectors are parallel like this. If two vectors are parallel like this, at that moment, what is angle between the two vectors? Angle between the two vectors is equal to 0, because these two are parallel. If vectors are parallel, at that moment theta is equal to 0. If vectors are parallel, theta is equal to 0, means P vector, Q vector, both are acting in the same direction. Two vectors are acting in same direction. At that moment, what is the resultant? Means R is equal to under root of P square plus Q square plus 2PQ cos 0. What is cos 0? Cos 0 is 1. R is equal to under root of P square plus Q square plus 2PQ cos 0, 1. So it is A square plus B square plus 2AB formula. A square plus B square plus 2AB formula if you write. So that is equal to under root of, here A means P, B means Q. So A plus B whole square, that is nothing but a P plus Q whole square. Square root get cancelled. So R maximum, when angle is 0, the resultant is maximum, that is P plus Q. R is maximum, isn't it? If you take the, what about this one? If you coming to the direction, tan alpha is equal to q sin theta. Theta is equal to 0. Q sin theta is nothing but a 0, and divided by p plus q cos 0, isn't it? Sin 0 value is nothing but a 0. 0 into something, 0. 0 by something, isn't it? That is nothing but a 0 by 1 is equal to how much it is? 0. 0 by something is nothing but a 0. So I am writing it is 0 by something is 0. Next one, if two vectors are, now I taken two vectors are parallel like this. If initially two vectors are like this, I taken like this now. Now I am taking two vectors are perpendicular to each other like this. If two vectors, this is one vector and this is one more vector. Two vectors are perpendicular like this. At that moment, if two vectors are perpendicular to each other, means theta is equal to 90 degrees. I am giving the direction like this. P vector, Q vectors, otherwise Q vector. This is P vector and it is Q vector. Angle between them is the 90 degrees. At that moment, again resultant R is equal to under root of P square plus Q square plus 2PQ cos 90. Cos 90 is how much? Cos 90 is 0. So at that moment, 0 into something is 0. This total part will becomes to 0. That is equal to under root of P square plus Q square, because cos 90 is 0. This is 0 means 0 into 2PQ. 0 into something is 0. So this part is 0. Remaining are P square plus Q square. That only I have written. R is equal to under root of P square plus Q square. Next one, tan alpha, if you write, tan alpha is equal to Q sin 90 all divided by P plus Q cos 90. Here sin 90 is 1. 1 into Q divided by P plus cos 90. Cos 90 is 0. 0 into Q is 0. So P plus 0 is the P we are writing. We can get it is Q divided by P. Tan alpha is equal to Q divided by P. Now if I am writing theta is equal to 180 degrees. Theta is equal to 180 degrees I am writing. Theta is equal to 180 degrees means first initially two vectors are parallel. Two vectors are perpendicular. Now two vectors are 180 degrees. Opposite direction means one vector it is P vector is acting along this direction and Q vector is acting along this direction. What about angle between them is 180 degrees. Two vectors are acting opposite direction, opposite to each other. At that moment, angle between these two vectors are 180 degrees. So you can write again formula R is equal to under root of P square plus Q square plus 2PQ cos 180. What is cos 180? Minus 1. Cos 180 is the minus 1. So R is equal to under root of P square plus Q square plus 2PQ minus 1. Minus into plus is minus. You can write here R is equal to under root of P square plus Q square minus 2PQ. A square plus B square minus 2PQ. We have to write P is nothing but a Q is nothing but a B. So A square plus B square minus 2PQ. That is equal to how we can write A minus B whole square. Means P minus Q whole square. Square root and square get cancelled. You can write P minus Q. This is resultant minimum or minimum. So minimum resultant is equal to P minus Q. Maximum resultant is equal to P plus Q. It is about the parallelogram application. You can write, you can explain, you can go through the 270 degrees, 370 degrees also. But majorly we are using X. Every time we can use it is theta. When theta is equal to 0, when these two are parallel, at that moment, when these two are parallel and perpendicular and also in opposite direction. These three cases majorly we are using application of the parallelogram law. Resolution of the vectors. See here. I will explain this resolution of the vector by using of the diagrammatically. I am taking one vector along this direction. This is nothing but along the x direction. And I taken one vector, it is A. Otherwise, for your understanding, just you can consider this is x-axis. It is only just you can consider x-axis. Now, one vector it is acting along this direction. That vector name is A. A given name it is nothing but A. This vector is making an angle with the x-axis is theta. A vector is making an angle with x-axis is theta. At that moment, for your understanding, I am just drawing here. From O to here distance we are writing it is nothing but AX. Magnitude is nothing but AX, isn't it? Now, this if you given this is A vector means it is A vector. This is B. This is C I am writing. Tan theta is, we can write it here, sin theta is equal to what you can write, opposite side by, sin theta is equal to opposite side by hypotenuse. What is the opposite side? BC. BC is opposite side and hypotenuse is A vector. Now BC is equal to, we can write it is A bar sin theta. BC is equal to A bar sin theta. This BC is parallel to the y-axis. This BC is nothing but a parallel to the y-axis, isn't it? So BC is acting along the y-axis. BC is acting along the y-axis. So I am writing this is A sin theta. A vector is A sin theta. And next I am writing cos theta. Cos theta is equal to adjacent side divided by hypotenuse. Adjacent side divided by hypotenuse. What is adjacent side? It is OB. Adjacent side it is OB. See here. OB divided by hypotenuse is A bar. So A bar if you take in this side, OB is equal to, we can write A bar cos theta. So this OB is equal to, I can write it is A bar cos theta. A bar cos theta. And this is nothing but A sin theta. This is A sin theta. This is A cos theta. Now we can write here A is resolving into the, A vector is resolved into the two components. One is horizontal component, one is vertical component. Horizontal component AX is equal to A cos theta, and A vertical component AY is equal to A sin theta. Vertical component is A sin theta. So when a vector is making an angle with the any, either it is y-axis or one more it is x-axis, whatever it may be, it can be resolved into the two components. It can be resolved into the two components. One it is horizontal component, one more it is vertical component. Horizontal component of A vector, horizontal component of A vector is A cos theta. Vertical component of A vector, is called A sin theta. So AX is nothing but a horizontal component. It is horizontal component, and this is AY is nothing but a vertical component, isn't it? Horizontal component is AX cos theta, AX is equal to A cos theta, vertical component is AY sin theta. Now, if you want to write this in the vector notation, if you want to write it is in the vector notation, A bar is equal to AXI plus AYJ, AXI, AYJ. If you take the Z axis, okay, later I will write this Z axis about this one, and tan theta is equal to, if you want to find out the direction, tan theta is equal to, this is AY, opposite. Tan theta means opposite side divided by adjacent side. Here opposite side what we taken it is vertical component is AY, isn't it? And adjacent side is nothing but a horizontal component, that is AX. So I am writing tan theta is equal to AY divided by AX. Tan theta is equal to AY divided by AX. If you take the Z axis also, for example, if you take the Z axis also, see here this is vector A vector, isn't it? It is A vector means AX is along the X direction, and AY is nothing but along the Y direction, and A along the Y axis, and AZ is nothing but along the Z axis. At that moment, A vector is equal to AXI plus AYJ plus AZK. Here I, J, K are the unit vectors. I, J, K are the unit vectors which are acting along the X direction. Here I is the unit vector along the X axis, J is the unit vector along the Y axis, K is the unit vector along the z axis. So magnitude of this vector means A bar is equal to under root of magnitude of this vector ax square plus ay square plus az square. It is the magnitude of the vector. It is nothing but a magnitude of the vector. A bar is equal to under root of ax square plus y square plus az square. For example, I will give one more example for you. Now I am taking, this is nothing but a 10 newtons force. Otherwise, one force is making an angle with the y-axis. F is a force is making an angle with the y-axis. At that moment, how it will be resolved? Again, F can be resolved into the two components. One is horizontal component, one more it is vertical component. Horizontal component is always cosine angle. Horizontal component is always cosine angle. You have to keep in your brain. Don't forget, horizontal component is always cosine angle. Vertical component is always sine angle. Vertical component is always sine angle. See here, horizontal component we got it is cosine angle. Horizontal component is the cosine angle. Vertical component is the sine angle. Mathematically we proved that one also. BC, it is the horizontal component. Sir, BC is nothing but a vertical component, that is a sin theta, and horizontal component is OB, that is a cos theta. So horizontal component is cosine angle, vertical component is the sine angle. Now F is resolved into the two components. One it is horizontal component, one is horizontal component is F cos theta, vertical component is F sin theta. Vertical component is F sin theta. Always these two components should be perpendicular to each other. Always the two components, horizontal component and vertical component should be perpendicular to each other. The resultant should be within the two components. See, one more for your understanding I am writing one more. See here. This is the, okay, this is, my name is, okay, for example, this is one blackboard, just it is the board. So B is a one vector, just I given this is nothing but a board. This is nothing but a one board, isn't it? So B, I given name, this is the B vector. This B vector is making an angle along this direction, with this direction is 30 degrees. With this direction is 30 degrees. At that moment, B is resolved into the two components. One is horizontal component, one more vertical component. So B is making an angle with this one. So at that moment, this is the horizontal component. Horizontal component is along this direction. So B cos theta, that is theta is nothing but a 30 degrees. Vertical component is B sin theta. Vertical component is B sin theta. These two components should be perpendicular. These two components is perpendicular. You have to understand here. See here, I have written it is appears to be vertical, but I taken this is horizontal component. Why I am taking horizontal component means this vector is making an angle with this one is theta. Now F is resolved into the two components. At that moment you have to write this one. This is the horizontal and remaining one is the vertical. See here. B is making an angle with this vector is 30 degrees. At that moment, this is horizontal component and remaining one is the vertical component. And here also, this A vector is making an angle with the x-axis is theta. At that moment, this is the horizontal component and remaining one is the vertical component. So this is about the resolution of the vectors. This is about the resolution of the vector.